Hi, welcome back again to China Manufacturing Decoded, the podcast from the Sofeast Group. Adrian here hosting today, and I'm joined by Andrew, our head of compliance, safety and reliability here in the group. Hi, Andrew. Welcome back.
Hello, Adrian. Good to be here.
Yeah, well, thanks for coming on. 2024. Can't believe how fast it's all going by already.
Oh my God. Yeah, you're so right.
Today's topic is understanding ESD, electrostatic discharge. And this is going to be a really good one for anyone who's interested in producing electronic products, of course, because this is particularly relevant to those types of products. So, Andrew, as someone that is regularly working with our customers who are producing electronics, I guess ESD is something that you do need to discuss with them.
Yeah, that's correct. You know, Adrian, the ESD is so important that I think that, you know, there are some people that may actually not realize how important this is. It impacts not only your electronics in terms of functionality, reliability, quality, but really it impacts your financial, it impacts your customers, it impacts your manufacturing goals and yields. I mean, it affects a whole bunch of areas, and it might even affect, for example, your manufacturing ISO 9000 basically registration and approval. So yeah, it cuts deep. So it's an important topic.
Great. Well, it looks like we've got a good one today then. And I'm sure the listeners listening are thinking, oh, if it's important, right, got to take some notes. And we're going to go through ESD basically all the way from what is it through to the types of testing that can be done, the problems that it causes. And I think a key point is how to prevent it as well, and lots more besides. So if we get started then, the big question, what is ESD?
Well, ESD in a nutshell is really like, basically static electricity. You know, that little zap you get when you touch somebody while you're on a carpet. Or I think the natural phenomenon is the thunderstorms. You know, you see the light coming down and touching the ground. That's basically one huge zap. And really, there's one main ESD type that is known, but how you test it might be different kinds or different ways.
Right. And of course, where electronics are concerned, this is not something that you want, you know, occurring within or touching your electronic devices if you can avoid it.
Absolutely. I mean, depends on what kind of electronics you have, but if you got ICs and the sensitive digital electronics or electronics that for some reason or another did not have any kind of protection designed into high voltage, even though the current level is low, the high voltage can actually cause a huge disruption, perhaps burn or melt your internal electronics. At the best situation, it might actually cause minor damages that you won't know, or might be intermittent until you've shipped the product.
Right. And as soon as you say that, I'm thinking, well, product reliability. Once again, this is something that needs to be paid attention to.
Absolutely. And that's one thing that we always do when we do reliability for our products. We make sure that they are passing the ESD right before we've completed our reliability and design process.
Interesting. Because, you know, I think probably most people's products, if you're listening right now and you're thinking, okay, I'm making a product, but lightning is not going to hit my product. So, you know, it's probably not going to be affected like maybe an airplane that could be struck by lightning. But actually, natural ESD like lightning and ESD that could affect an electronic device, there is a link there, because although your device might not be hit by lightning, it may still get affected by ESD. And I think you're going to go into that, aren't you?
Yeah, we will. And there are a lot of people that, for example, have been zapped by a huge lightning that went through their TV and actually burned their TV. Some of those old digital TVs didn't have protection, and you had to actually buy ESD control. I don't know if you remember breakers and switch breakers and some kind of a, what do we call
Mm.
it? Plugging your TV through this protective element. We don't do that anymore. Most of the TV,
Right.
you know what I'm talking about, right?
Not really, Andrew. I'm sorry. I think it might be a bit before even my time, and I'm not getting any younger.
Yeah. Well, I'm talking about, like, for example, yeah, that's true. Actually, these things are getting a lot more modern now. But in the olden days,
Mm.
you did have to have, a separate unit that you had to plug that in
Right.
through the wall, and then this protective element would break and burn in case, or the fuse would blow, and then
Right.
your TV wouldn't burn. So you had to plug in your TV through that.
Yeah, because you've got an aerial on the roof, and that's basically
Yes, exactly.
working as a lightning conductor.
Exactly. But then sometimes, if the wiring in the house is not well grounded,
Mm.
good, some of the appliances within the house, TVs and some other items could actually get zapped by the traveling,
Okay.
voltage through the house. So it could happen. Um,
Okay. Yeah, I
so
don't think anybody really thinks about that these days. Maybe modern appliances are kind of protected against that.
absolutely, absolutely. And we'll get to that,
Okay.
how to prevent some of the prevention elements of the ESD.
Yeah, yeah, yeah. Okay, so at this point, you've explained what ESD is, and we've also kind of discussed about some of the things that we want to be avoiding, such as the damage to various appliances. So the next port of call here then is to talk about testing, because we want to make sure that our devices are resilient to forms of ESD. And so the way to do that is through testing, right?
Absolutely. And that's what I was referring to earlier about different ESDs. There are really three different types of ESD testing so that we can actually recognize that, the product that we're building is protected against ESD. One that is the most common is called human body model, HBM. This type of testing simulates the discharge from a human body to an electronic device. So this
Hmm.
is really a good test because all you need to do is hold a device in your hand. And if you are charged with ESD, you can definitely zap that product. So you want to make sure that that product has basically designed well against and protected against ESD. And some of the advantages of that kind of a human body model is that basically creates and represents real world scenario of involving human beings, touching these electronic products, right? And
Hmm.
this type of testing is widely accepted in the electronics industry worldwide, pretty much. And it's relatively straightforward and cheap to execute. So I think this is one of the tests that I would definitely recommend at the least, at the minimal, to especially consumer electronics.
Okay, I like the sound of that. It's effective but cheap. Nothing
Yeah,
better.
absolutely, absolutely. The second model is called machine model, sometimes short for MM. And this one basically simulates how ESD events can happen in manufacturing machinery area. Like one machine touches another machine by chance and maybe discharge some electricity. And the way the basically discharge happens is, as you know, capacitors in many machines hold charge, and in some cases they may actually discharge. And of course, like as we were saying before, a lot of these have been modeled in a way and designed in a way that they're not happening as much anymore, but still good to know these things as a designer so that you're checking and making sure that you have a protective element towards protecting your product and your design towards ESD. Well, some of the advantages of this one is that it really mimics and checks your real manufacturing ESD issues. And then compared to human body model, this one has faster discharge time and can identify vulnerabilities in automated production process. So those are some of the good advantages I think that is important. Now, the third model is called charged device model, or CDM. This is when you're simulating or testing the discharge that occurs when a charged device comes into contact with a grounded object. For example, you don't want to be the guy grounded when the lightning hits you. So you're going to be toast in between the ground and the lightning. One of the advantages of this type of testing is that it represents a fast and efficient way of knowing if ESD actually going to hurt the equipment. And it's highly relevant, to scenarios involving automated handling and packaging process. You know how sometimes packages involve plastics and paper and humidity, and these things actually do cause ESD. And so I think generally speaking, these three types are worldwide known, and depending on different types of products and different kind of industry, you have different levels of voltages that you need to test for.
Okay. Just to ask for a second, right? When we are assembling, let's say, electronic devices for our customers at Agilian, our contract manufacturing subsidiary, sometimes I see our operators, they're wearing like a little cuff, which is grounding them. So that's part of this prevention of ESD, right?
Exactly. So yes, most of the assembly line workers have basically, you called it cuff, but what we call it like ESD bracelet that is basically touching your body, and then you plug it onto your desk, and your desk is ESD protected and it's plugging into the ground. And that's the whole point of that. You want to make sure that if you are charged, then you are grounding yourself and you're discharging against the ground, not against the electronics.
But of course, users, they're not going to be plugged into a ground or an earth. So that's why we are trying to make sure that the product is designed and tested to be resilient to ESD. Okay, good. So let's talk a little bit then. We know the sorts of tests that you're suggesting, and that's very, very clear. But just before we move on from tests, actually, if you're engaging a testing lab in wherever, China, India, could be anywhere, right? In Europe to do testing, and they're going to test for ESD resistance. What would most labs be able to do this pretty easily?
Yes. ESD testing actually is not too difficult anymore. And the test equipment are not so expensive. I think you can invest anywhere from 10,000 USD to 20,000 USD, depending on how many different kind of equipment you want, the capability of testing all at the same time. And basically, ESD is tested for two ways. One of them is basically a touch test. So you take the ESD gun, which is called, and you touch it directly to the product, different points. And this is when, that product comes in direct contact with a charged ESD, either a human being or machinery, right? So that's what you're testing. You're simulating that environment. And in that case, there are different voltages for the industry for different products. Maybe some products are not going to experience high voltage. So maybe you would do, for example, 4 kilovolts on the touch and 8 kilovolts on the air. So air is another one. Why we do the air is, remember that we discussed, when you touch somebody, before you even touch somebody, there is like an air gap of maybe 1 centimeter or 2 centimeter. The charge actually jumps and zaps that other person without even touching. So that's the simulation. You do an air touch, basically air test, where there's a gap, but then you have to do a little bit higher voltage. For example, instead of 4 kilovolts by touching, you might do 8 kilovolts by air. And in some other electronic equipment, maybe the requirements are higher because it's going to be touched by way too many people in way too many environments. So you want to basically lower the risk of ESD damage. So in that case, the requirement is higher for the touch voltage. So maybe it will be like 8 kilovolt, and then the air voltage will be more like double, 60 kilovolt. And again, depending on different products, you could go higher and higher, maybe like airplanes, airspace. The requirements are way high because you're dealing with actually direct impact right in the air, with the cloud.
Of lightning.
Yeah, lightning.
So that's about as much as you can get, really. Yeah.
Right.
Right. So this is actually connected to the labs then. So it's good that you're talking about the voltage levels for the different electronics, because when we're engaging the lab and we're telling them, okay, we want to do ESD testing, as you've established, this is pretty commonplace for most labs, which is good news for anybody manufacturing electronics, but you're going to be relying on them to have a good idea of the sort of voltage levels they're going to be testing for that's suitable for your electronics. I mean, you're giving a basis here, but if they're able to do the testing, they're probably going to know which voltage levels are suitable as well.
Yeah, exactly. I mean, for consumer electronics, like I said, the most acceptable ones are between 4 kilovolts and 8 kilovolts for less handled product, and then 8 kilovolt and 16 kilovolt for most handled by hand or by human. But then you could go to industrial electronics, and then the level, or for example, medical devices, like automotive or aerospace, the level just keeps going up. Maybe like, for example, for automotive, you need, more than 1500 volts. I mean, that's huge, right? So, and then in the same way, it starts going different direction for different industries.
Yeah. Okay. Yeah, that's clear. That's good. All right. So let's move on then. We know about the testing. You've given insight into the different voltage levels, which is really helpful. We've touched on, but we haven't covered a lot the types of harm or damage that can be caused by ESD. So putting it all into order now, right? We're doing the testing, but this kind of addresses why we're doing the testing. So, this is what we don't want because of ESD.
Yeah. The harm that can come from ESD is huge. Many times, if there is a design issue, a serious design issue, you will probably know it very quickly, and you'll find out as soon as the ESD test is done. However, if you don't do ESD testing, then what will happen is that the product will either go through some ESD damage during the production or during the shipping process, and or once it arrives at the customer hands, you'll have huge amount of returns due to ESD damages, which cause the device to be dead on arrival, right? And then you will have massive customer complaints after they used it for a few times. They were in a situation where they were charged and they touched the device went bad, dead, and they have no idea what happened. Oh, I just touched it and I just opened it. I just turned it on and all of a sudden, boom, it's not working anymore. So not testing for ESD, you'd face huge returns, massive customer dissatisfaction, probably a recall if it's a very important device, life-saving device, for example, a medical device. You probably need to have a recall and fix it, or else we're looking at lawsuits, massive financial, and possibly some health issues in terms of people getting hurt because of the product actually maybe catching fire just because of the ESD. You never know.
Right.
So if you test even the minimal for ESD, you're going to be a lot safer than nothing at all. Now, if you don't test it, even at the minimal, you're looking at in some kind of a massive problem to deal with later on after production.
Unless you're lucky. But so potentially especially for electronics. So the message I'm getting here is that, and we've spoken about different types of testing and product reliability a number of times, especially with yourself, because this is your area of expertise, right? And so what you're saying is that for electronic products, then ESD testing is one of those that should be really high at the top of your list of priorities to do.
Absolutely. The same way that you and I have discussed before, that reliability testing is critical and crucial.
Yeah.
For knowing the health of your product in terms of what your goals are for the reliability of your product is just the ESD is just as important in that there are external factors such as static electricity that can damage your product, make it useless, cause, in some cases, fire because of the shorts and things that can happen. And so it is critical that you do at the minimum, whatever that minimal requirement is for your product, do minimal ESD testing to ensure that you have some kind of preventive or protective system built that doesn't cause your product to be disabled as a result of ESD.
Right. There you go, folks. That's the takeaway already, but we're not finished yet on this topic. And it's funny though, but when you're thinking about a product, right, me as a consumer, if I go buy an electronic device, right, I'm going to buy it, get out of the box, plug it in, charge it and use it. I will never think, could I be the cause of my product dying if I just touch it and then there's a shock and then it shorts it out and the product's dead? Yeah, consumers don't think like that. So we're taking that out of their hands.
Yeah, it could be. But again, I think that I would leave the blame on the design of the product that is protected by ESD. Of course, if you did something unusual that caused a massive out of ordinary ESD, for example, you put your product on top of the umbrella in a rainy day, but in general, in today's world, I think most people don't do anything crazy. We're not talking about some outrageously unusual use cases, but we're talking about in the day-to-day, use cases. Most people who cause damage as a result of ESD I should not be liable for the damage of that product.
No, absolutely. But unwittingly, they might be a cause of it. Although I do like the point that you're making. If somebody, let's say you're walking on your synthetic carpet and you're sitting on your synthetic couch and you're sort of I don't know, you've been rolling around on the floor playing with the dog. So you've built up this static charge in your own home, and then you go touch your electronic device and bang, it's, it's been damaged because of the ESD. What you're saying is you would be saying, well, has this device been designed to be resilient enough? Should we be looking at the product design and going back to that? And I think that's a really good point. I mean, in today's home, there are ways that you can, as a consumer, unwittingly, produce an ESD charge, a static charge. Sometimes if you just sit next to somebody on the metro, like you said, you might have a zap, So these do happen, but I do like that we're thinking more about the design. Why is the device not resilient to begin with? And that brings me on to the next point, which is, how to prevent the effects of ESD. We're not going to prevent ESD itself. That is a static charge that can be caused by anything, even lightning, like you say, right? But there are like tips and strategies for actually preventing it from damaging the product, right?
Yeah, and I want to kind of go back on what you just said in terms of causes of the ESD. Yes, you're right.
Okay.
Human body contact, people, exactly what you said. You sit next to someone in the subway and all of a sudden you get discharged. You never know where it's coming from, but yes, that is the case we're talking about when you're actually building up the charge. You don't know about it, and then all of a sudden you start touching electronics. Sometimes it comes from friction, rubbing two materials together, and one case is basically your shoes rubbing against the certain kind of a carpet. And then, of course, inadequate handling procedures, for example, in manufacturing environment, if you are not wearing ESD protected suits, or wristband is what we call ESD wristband. Or if you don't have ESD protected mats, these are the blue mats that usually when you walk into the manufacturing area, you have these things that you have to actually touch. And not only it takes away the dust from your shoes, but also it's ESD protective. And then you get onto ESD zapping machine, which actually discharges you and gives you green light. Yeah, now you can go ahead and move along the manufacturing area. So, and then of course we're talking about manufacturing floor. We'll touch base a little bit more detail in later on if we have time. But we're talking about assembly lines, assembly workers, all wearing wristbands, ESD protected wristband, ESD protected little suits or clothing. I don't know, what do we call those these days? So basically coats and jackets, hats, all of these are related and conductive for ESD. And then
they wear rubber sandals as well.
Correct. And then all of that is connected to ESD protected desktops, all these chairs and tables that are all grounded. In fact, the entire manufacturing floor is ESD conductive. Is basically grounded. I know you've seen those floors being either blue or green. It's a special material that actually makes sure that everyone is grounded on that floor. So you don't take your charger with you and then, you touch a product during the manufacturing. So yeah, and then there's another element that happens, and I think we touched on that just briefly, and that is the transportation. During the transportation of the product, when they wrap the product into plastic, if you remember how, those pallets are wrapped with plastic, that's actually causing ESD and you don't realize it. And then they put that next to another pallet with plastic, and then they try to minimize the space in between. Well, during the transportation, these are rubbing each other and causing huge static electricity that, if your product inside those boxes are not grounded and not protected, you could have some issues, and then you'll have a lot of dead on arrival.
Good point. Yeah, those are good points actually, because when we are looking at our manufacturer, let's say you're going to outsource the production of your electronics, right? You want to make sure that your manufacturer is well set up to try to prevent issues on the manufacturing side. There's always kind of two ways, isn't there? There's the design, there's potential problems with product design, but then you've got manufacturing issues, which could come down to the environment and the processes. And those are kind of even worse, because if you've gone through all of the design process and the development process and the product is, as perfect as it's going to get, but then you get let down by the factory, that's really bad. So these things, I suppose, when we are auditing and assessing our manufacturer, you want to make sure that they've got these preventative methods in place.
Yeah, preventive methodologies or methods are totally important. And for example, in manufacturing area, we're talking about, for example, and not just only manufacturing, but also like during the development and design, you got teams that have their own engineering labs and so forth. So you want to have anti-static mats or anti-static materials that basically anti-static workstations, anti-static packaging, So you want to make sure all of these are taken into account when you're building a lab, for example.
Yeah.
Then proper grounding techniques. We talked about, for example, personal grounding like wristbands and connected to workstation grounding and even equipment grounding. I'm glad I remembered that. That's when you got an equipment that is actually testing your product. And boy, imagine if it's not grounded and you just touched it to PCB, your board is toast, or your chip in the board, chip on board is toast. So it could happen. And believe me, a lot of the design engineers have a lot of stories to talk about. Then, of course, we're talking about ESD protective equipment. That's like personal protective equipment. We're talking about the jackets, and they call it anti-static smocks in the labs or in by the assembly worker. That's the word I was looking for, smocks, because basically, these are special clothing that actually conduct static electricity. And then once you connect it and to the ground wrist strap, they eliminate it by grounding. And then you also need to have ESD safe tools. This could be any kind of tools that you need to use in the production environment. You need to make sure these tools are not carrying any kind of a charge. Maybe they have, plastic handle, or maybe they don't. But either way, you want to make sure that they're not carrying charge. And the most important thing is training your teams. They, in the production environment, of course, training is a must. So everyone must go through the proper training of understanding that, okay, you must wear this smog in this area. You must have a wristband. You must connect your wristband to the workstation. You must have, a test and discharge yourself before you go to your workstation. All of these need to be ingrained into the production environment. People who work in those workstations, they really, really need to understand this is the only way. You can't shortcut and, I was in a hurry and I didn't discharge myself. No, it's not acceptable. It can really cause mayhem in the product. Of course, the two other items that I think it's worth talking about in terms of prevention. One is humidity control. When average humidity is what, like 50%, I think, something like that. Right. And that's okay. And that's good. But what if the humidity went down and you have less than 30% humidity? Then you're looking at dry air and dry conditions where it can actually cause more static electricity. So you want to make sure you have normal environments and humidity is being monitored and controlled. And then the most important thing in, let's say, manufacturing environment is to have, as part of the quality, right? You need to have continuous improvement process in place, that you're doing regular audits and assessment of the manufacturing floor and people and teams and the processes. And you want to make sure that these audits always catch if there is anything that is basically not, or anyone that is not following the ESD preventive measures.
Mm-hmm. Yeah. So we've looked at kind of like external ways to prevent ESD, and that's really helpful. I mentioned earlier on about designing the products, because you mentioned design actually. So maybe we can talk a little bit about product design to prevent the ESD effects.
Yeah, I think that one of the things that probably need to be done at early stages of the design is just to have a real quick ESD done on the first prototype. Of course, you want to make sure all your components are resistant to ESD. You need to understand what is the ESD level requirement for your product. For example, there's a big difference, right, between an airplane, which is not a consumer product, and then your iPhone. Of course, your iPhone is going to see huge ESD. You're touching it all the time, but it's nowhere near ESD voltages coming from thunderstorm, for example, on an airplane, right? So you need to design your product for that environment. And then you need to test it for that environment. And that means that you need to know, for example, when it comes to compliance, what standard applies to your product in terms of ESD compliance. Is it ISO? Is it EN? Depending on what countries you're going to sell, for example, you want to make sure that your product is going to meet the ESD requirements for that. If there is any ESD requirement, sometimes ESD is kind of, added into the UL safety. So you need to kind of be aware of all this. And as a design manager, you need to basically teach your team to be aware, designing a product that is going to be safe and ESD resistant.
Okay. Yeah. So add it to the list, but for electronics, I mean, that does make perfect sense. Absolutely. Okay. So we've pretty much gone from the origins of ESD and natural and unnatural, I suppose, things that could occur, from you just going around in your home or even in the factory, through to the types of ESD testing that you might want to do. And the good news is, as you said, they're pretty affordable and very effective if you are bringing electronic products to the market. And, damage that can be caused by ESD, and importantly, how we prevent it. But if we just wrap up then, and then I think we're good, because that's been a really good overview, Andrew.
Yeah, I think just as a wrap up, I would say for most experienced design engineers and manufacturing leaders, they know what is required when it comes to ESD. But just in case, if someone forgot about it, I would say during the design and development phase, make sure you have all your workstation and test station engineering labs are all ESD protected. And make sure when you are designing your product, you look at the data sheet and see whether there is a ESD requirement, ESD protection requirement. For example, you need to actually design a certain kind of a electronic circuitry to protect your IC or your design from ESD. So you need to be aware of that as a designer. Then you need to definitely test it. A quick test doesn't cost much. When your prototype is ready for reliability testing, you can also do maybe at the end, after you've gotten all your design data, including reliability data, then you can probably do 2 more tests real quick they call it compliance screening test, and also ESD test. These two, along with reliability testing, will bring out and detect all kinds of issues that you could have as a result of reliability, quality, ESD, and compliance. You need to cover all of these during your design and development phase. And once you go to your production, you need to make sure your manufacturing is ISO 9000 compliant, which also includes ESD protection. And that really covers a whole bunch of areas, including ESD protected mats, ESD testing, ESD wristbands, ESD workstation, desktops, everything, machinery, equipment. So, and then once your product is fully produced, at least maybe at early stages, you want to run one more time all of these tests. Maybe you want to ongoing reliability testing just to see if production didn't cause any harm as a result of ESD and or other. So that's why you do ORT, ongoing reliability testing. Then you could also send one of those devices to run full ESD based on your ESD requirements. And then you could even, if the compliance hasn't been done yet, you could do it at that stage, basically right at the start of the production when everything goes well. Then you do one more compliance test. If you can do these harmonically, then most likely you'll avoid a lot of customer issues, field return issues, and financial disparity.
Yeah, that's absolutely what we want to avoid. And all of the types of testing that you talk about, reliability testing, ESD testing, fundamentally, we want to make sure that those products aren't coming back. And that does remind me, you've already written some really good blog posts about this, about product returns and avoiding them on Agillion. So I'll definitely share the links to those in the show notes and any others that are relevant here. So to everybody listening, ESD and ESD testing is a must if you're bringing electronic products to market. And I think that's the big takeaway from you today, Andrew. Thanks for joining us.
Thank you, and Adrian, for having me. I appreciate it.
Excellent. We will be back next week as normal, so keep it locked and tune in then. Thanks again for listening to this podcast brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share because it will really help others discover us too.